In this video, we are going to use the completing the square technique to find the roots or the zeros of quadratic equations. We're going to start with these two examples over here, which really are not part of the completing the square technique, but in order to understand how to solve quadratic equations, we're going to need to start somewhere. So I have over here 3x squared minus 4 equals 68, and I need to get x all by itself, and this is going to tell me what the roots of the equation are. So we'll start as we would with any algebraic equation. Add 4 to both sides. That'll give me 3x squared equals 72. I need to get the x by itself, so first I have to divide both sides by 3. And that is going to give me x squared equals 24. And now I need to get x all by itself, so the exponent here, the 2, needs to disappear. We take the square root of both sides. The square root of x squared is just x, and the square root of 24 is plus or minus the square root of 24. We can also simplify this radical, which I'll do over in this little space over here. Square root of 24, square root of 24 can be broken down into the perfect square of 4 times the not perfect square of 6. This gives us 2 root 6. So our simplified answer is x equals plus or minus 2 root 6. Those are the zeros for this equation. If I were to plug that into here, we would end up with 68, and if I moved the 68 over to here and had the equation equaling 0, it would equal then 0. This side, we're going to do pretty much the same thing, except notice that I don't have a binomial, I have a trinomial over here. I need to factor this down, or as I like to say, we need to condense this down into a binomial. Now, since we have a perfect square over here, and we have a perfect square over here, we have what is possibly a perfect square trinomial. So I'm going to start by putting my parentheses in with the square, and I'm going to take the square root of x squared, which is x, the square root of 25, which is 5, and I'm going to check to see, is this a perfect square trinomial? It is a perfect square trinomial if I multiply this times this, so x times 5 is 5x, and I double it. If when you double it, you get the middle number, positive or negative, doesn't matter. As long as you get the middle number, it is a perfect square trinomial. So 5x times 2 is 10x, and in order to finish this off, we take the sign then from our middle term. And we have x minus 5 squared equals 27. Alright, now solving this is just like when we got to here on the other side. I need to get the x by itself, so first I have to undo the square root. Undo the squaring. So I'm going to take the square root of both sides. This gives me x minus 5 equals the square root of 27. Now, just like over here, where we simplified the square root of 24, the square root of 27 can also be simplified. It can become the square root of 9 times the square root of 3. So it is really 3 root 3. That is what x minus 5 equals. It is 3 root 3, and I forgot to mention this earlier, sorry, but since we took the square root, it's the positive or negative square root of 27, which means it is the positive or negative 3 times the square root of 3. Our solutions then, when I add 5 to both sides, are x equals 5 plus or minus 3 times the square root of 3. And those are the solutions for our equations. Now at this point, we are ready to start talking about what is completing the square and how do we do it. So let's take a look. In this example, we have x squared plus 4x plus something. We don't know what this something is right now. What we're going to put here is what is going to complete the square for us. When we say we're completing the square, we're trying to take this trinomial, that it will eventually be, and condense it down into a binomial that is squared, a perfect square binomial. And the way we do that is we take the middle term, specifically the coefficient. This middle term in standard form is b, and the formula for, so this is b, and the formula for completing the square is b divided by 2 squared, and then we take that and put that at the end. So, in this case, our b is 4, divided by 2, and square it. That gives me 2 squared, which is 4. So, to create a perfect square trinomial, I had to put a 4 at the end of this expression. Now, this is a perfect square trinomial, and I can condense it down like we did in that last problem. I have a perfect square on the front, which is x. I have a perfect square over here, which is 4, and the square root of 4 is 2. And then because b is positive, we will have x plus 2 squared. And we have now successfully completed the square and condensed it down. The reason why we use this technique is it allows us to solve for the roots of our quadratic equations without having to use the quadratic formula. The quadratic formula is sort of like the big powerhouse where if we can't complete the square, or it's going to turn out ugly, we use the quadratic formula. But if it's not too bad, completing the square is a great technique that takes less time than the quadratic formula. Let's try another example. Here we have x squared plus 3x plus something, and once again we are trying to complete the square so that we can condense this trinomial down into a perfect square binomial. Just like before, it all hinges around b, our single x term. We're going to take that 3, cut it in half, and square it. Now, in my personal opinion, it's easier to deal with fractions than decimals, so since I can't actually divide 3 by 2 and get a whole number, I'm going to leave it in this fraction, and I'm going to square it. So that means our 3 over 2 squared becomes 9 over 4, and that is going to complete our perfect square. X squared plus 3x plus 9/4. Now, to condense it down, just like we have done before, we'll take the square root of x squared, which is x, and the square root of 9/4, which just so happens to be this right here. That is a key. It'll always be that part right there. So, we have x, we have 3 over 2, and because b is positive, we are adding. And we have just, once again, successfully completed the square and condensed down our trinomial. Now, let's move into actually working with an equation, because when we start having these equal something, when we have them equal something, it's going to add just a little bit of an issue for us, but we should be able to handle it. So let's take another look, or a new look at solving a quadratic equation by completing the square. Alright, x squared plus 6x equals 27. We have a quadratic equation here, and we are trying to complete the square so we can figure out what values for x are going to make 27, or if we had the 27 over here, what values of x would make this equation equal to 0. So we're going to start by completing the square. And whenever you have one of these equations, you need your x's on the same side. So if this equation was written as x squared equals 27 minus 6x, if it was written like that, we would have to move this minus 6x over to the same side as the x squared, like we see here. They need to be together. So we are going to complete the square, just like we did, before, and we are revolving around this 6x. What is 6 divided by 2? Squared? Well, that's 3 squared, which is 9. So our first move is to add 9 to the left side. X squared plus 6x plus 9. Oops, let's do this in a different color. Plus 9 equals 27. I have a little bit of a problem though. This 9 that I just added to make the perfect square so I could complete the square unbalanced our equation. If you think of our equation as a seesaw, right up here the seesaw was level. Our seesaw is level because we are balanced. X squared plus 6x equals 27. That's what we were given. But now that I have added 9, our equation has become unbalanced. Our seesaw would look something like this, because the left side is now too heavy. It has something that wasn't there before. We need to rebalance the equation so we can solve it. And what we're going to do to rebalance the equation is I added 9 to the left side. I'm going to add 9 to the right side. That way, the amount I added to the left and the amount I added to the right cancel each other out. It's almost as if I did nothing to the problem. And this allows our seesaw to once again be balanced. Alright, I can condense down our perfect square trinomial over here like we've done several times so far. This is x plus 3 squared equals 36. Sorry, my pen for some reason is not writing. Equals 36. This looks a lot like what we just started to do, or started the video with. We have a squared term, we have an answer, and we need to solve for x. So we're going to use the same techniques that we started off this video with. We are going to take the square root of both sides. That gives me x plus 3 equals plus or minus 6. And now we are going to solve. X plus 3 equals 6, and x plus 3 equals negative 6. Subtract 3 from everything on both equations, and our roots or our zeros are x equals 3 and x equals negative 9. And we have successfully solved our roots. This is a long problem, but we were able to make it through it. I have one more problem we're going to try to do together, and then that's going to be it, for this video at least. So let's jump into the last problem. Here we have our final problem, 2x squared plus 8x minus 15 equals 5. We're going to use the completing the square method to figure out what values of x make this equation true. And to start off, we are going to make our x terms, the 2x squared plus 8x, the only pieces of math we have on the left side. We're going to get rid of the minus 15. So let's start by adding 15 to both sides. And we have now 2x squared plus 8x equals 20. Alright, now I'm going to do something a little unorthodox, but it will work, and you'll see why. I'm going to factor out a 2 from this side. I'm going to make sure that I have a perfect square to start off with, and right now I don't. 2 makes it not a perfect square. So I'm going to factor a 2 out, and that's going to give me 2 times x squared plus 4x equals 20. I'm now going to complete the square with this term. x squared plus 4x. The 2 will be brought back in eventually, but right now it's just going to sit out here. X squared plus 4x, I need my third term, so that, as we have done, relies with the b term, the 4 divided by 2 squared, which is just 4. So I have a plus 4 there. Now, as we saw in the previous example, right now we added something to our problem. Our seesaw is not balanced. It's too heavy on this side because I've added something. But we are not going to add 4 to the right side to balance it, because that won't work. Because really, we didn't add 4 to the equation. We added 4 times 2. So if I want to balance this equation, I'm going to have to add 8 to the right side. Because what is 2 times 4? It is 8. Now I can condense this down. That gives me 2 times x plus 2 squared equals 28. And now we can go about solving this as we have done with all the other problems. We're going to start by getting rid of the 2 on the outside through division. That gives me x plus 2 squared equals 14. We're going to take the square root of both sides. That's going to give me x plus 2 equals the positive or negative square root of 14. And we can't simplify the square root of 14. There's no perfect squares in it. And then we will set it up as x plus 2 equals the square root of 14. X plus 2 equals the negative square root of 14. Subtract 2 from each of our equations. And our solutions are x equals negative 2 plus the square root of 14, and x equals negative 2 minus the square root of 14. Hope you found this video useful and you are able to successfully complete the square. This is part 1 of my completing the square videos. We're going to have a part 2 where we talk about how can we use completing the square to change the standard quadratic equation into the vertex form of the quadratic equation. So, hope to see you with that video, and good luck.